Okay, problem number 27. Solve the equation for y. It means I need to get this y so that the end equation is going to have y isolated by itself. So the first thing I'm going to do is I'm going to rewrite it. I'm going to add 3x to both sides. So if I add 3x and add 3x over here, I'm going to get a negative 2y is equal to 3x minus 6, right? Because I added 3x. Now I'm going to divide both sides by a negative 2. So I will have y is equal to, now this negative 3x is going to be all over a negative 2. So that would be a minus 3 halves x. And this minus 6 and minus 2 would also be together as a fraction. That would be a plus 3. Negative 6 divided by 2 is plus 3. Next one said solve the equation for x. So this is the x here. So a is equal to n x plus 7 all over p. So I have this n over p that I need to get out of there. So I multiply by the reciprocal, p over n. It means I have to multiply this side by p over n. Of course, that a is over 1. So I'm going to end up with pa all over n is equal to x plus 7. We want to get the x by itself. So we just simply subtract, looks like, well, x plus 7. So we're going to subtract 7 from this side and from this side. Pa all over n minus 7 is equal to x. So that's one correct answer. If I wanted to, and I wanted to have it so that the pa and the 7 are both over a common denominator, this is what I would have to do. Pa all over n minus 7. And now I'm going to want to take the 7 times something to give me a common denominator of n. So I would take it times n over n. And that would give me pa over n minus 7n over n is equal to x, which then can be combined so that it's pa minus 7n over n. And that would be the other way I could express that, by just making the 7 combined with the p over a as the numerator by giving it a common denominator. Okay, let's look at what we have here. We have some inequalities. So anytime I divide or multiply by a negative, I'm going to have to switch the inequality sign. So I have a 3 times a negative 1 plus 4x is less than or equal to 45. And let's get that 3 out of there. So I'm going to divide both sides by 3. And when I do that, I'm going to have a negative 1 plus 4x is greater than or equal to 15. Now I didn't divide by a negative, so the sign doesn't switch. I'm going to add 1 to both sides. Adding a 1 to both sides gives me 4x is greater than or equal to 16. Dividing by 4 gives me x is greater than or equal to 4. Now this is not a compound inequality. There's no two sides linked with an or and and, so I can just simply graph that right away. That's going to be a closed dot because it's an equal to in the inequality, and it's everything greater than 4. Okay, next one is, let's go ahead and rewrite it. Okay, let's subtract 4 from both sides. So that would give me a negative 2. And if I subtracted 4 from this side, I would have 7 plus n. Alright, now then, let's go ahead and distribute this 2 in. So that would be a minus 8n. Negative 2 times 1 is a minus 2. Is greater than or equal to 7 plus n. Let's subtract n from both sides. Actually, yeah, let's do that. Let's do that. So subtracting n from both sides would give me a minus 9n. Minus 2 is greater than or equal to 7. Now I'm going to add 2 to both sides. So add 2 to both sides right here. I get a negative n. is greater than or equal to 9. And now I'm going to divide by a negative 1. And when I divide by negative 1, it's going to flip that inequality sign. I'm not going to divide by negative 1, I'm going to divide by negative 9. Sorry, let's try this again. Negative 9. Let me erase it. Okay, so dividing both sides by negative 9. This is going to flip the inequality because divide by negative. I'm going to have n that flips negative 1. That's a less than or equal to. And that's the end of that section.